Hey, it's Mrs. Weethy here, and we are going to discuss our last lesson on yields. And so your learning goals are, by the time you're done, you will be able to determine the theoretical yield from a given amount of reactant. You'll be able to differentiate between theoretical and actual yields, and then you'll be able to determine the percent yield from the theoretical and actual yields. Okay, so to yield in chemistry means to produce, not to go slow or give somebody else the right of way, but it means to produce. Yields are nouns, and these are products, and there are two types. We have the theoretical yield, and the theoretical yield is the expected amount of product in an ideal situation. It is determined through stoichiometry. The actual yield, on the other hand, is the amount of product actually obtained in the chemical reaction. It's determined from laboratory data or given to you in a problem. So let's take a look at a hypothetical problem. Suppose that the theoretical yield for an experiment was calculated to be 19.5 grams. Now that would have been determined through stoichiometry using the limiting reactant. And the experiment was performed, but only 12.3 grams of product were recovered. And when we say a product was recovered, it means that's what we actually got in the chemical reaction. Determine the percent yield. So what do we know? We know that the theoretical yield is 19.5 grams based on the limiting reactant. We know that the actual yield is 12.3 grams that was experimentally recovered. This is the equation for percent yield. Percent yield is equal to the actual yield divided by the theoretical yield times 100. Apply your numbers. 12.3 divided by 19.5 times 100, that gives us 63.1% yield. What does that mean? That means of what we expected, 19.5 grams, only 63% we got back in the actual reaction. What contributes to this? Well, there are a lot of different factors that affect a chemical reaction. Another factor that contributes to percent yield would be experimental yield or experimental error. And lots of different kinds of error that can happen during a chemical reaction. All right, so let's take a look at a problem. If a reaction vessel contains 120.0 grams of potassium superoxide and 47.0 grams of water, how many grams of oxygen can be produced? All right, so let's list what we know. And look at that. You have amounts of two reactants. Well, what do you know? What do you have to do whenever you have the amounts of two reactants? Yep, that's right. You need to find the limiting reactant first. So convert both of your reactants to moles using the formula mass. And then you're going to take one of those reactants and convert it to the other reactant. So I'm going to start with 1.688 moles of potassium superoxide, and using the mole ratio, I'm going to convert that to the moles of water. Divide out the common unit, and that gives me 0.8440 moles of water. That's the amount of water that is required. Compare that to the amount, the actual amount, and we see that the actual amount is greater, thus water is in excess. That makes potassium superoxide the limiting reactant. Now we can use the limiting reactant to find the number of grams of oxygen. And since we already know the amount of moles of potassium superoxide because we already calculated it, we can start with, in our plan, the moles of potassium superoxide. So moles of potassium superoxide to moles of oxygen to grams of oxygen. And now solve the problem. Multiply by the mole ratio, divide out the common unit, multiply by the formula mass, divide out the common unit, and we get 40.5 grams of oxygen. That is the theoretical yield. That's the amount that is expected to be produced. Now, let's answer this question. If only 35.2 grams of oxygen were recovered, what was the percent yield? All right, so our theoretical yield is 40.5 grams of oxygen, which we just determined through stoichiometry. The actual yield is given to us, 35.2 grams. That was from the question. And we'll use the percent yield equation, plug in our numbers, and we get 86.9%, which isn't too bad. So what does that mean? That only 86.9% of the expected amount of product was actually recovered, what we actually got in the chemical reaction. All right, so now it's your turn. When potassium chromate is added to a solution containing 0.500 grams of silver nitrate, solid silver chromate is formed. So I want you to determine the theoretical yield, and then if 0.455 grams of silver chromate is obtained, then calculate the percent yield. Hey, take a look at this. You only have one reactant, so you don't have to figure out the limiting reactant. Yay! All right, pause the video, and I want you to solve this problem, then come back and we'll go through the solution. Okay, so now that you have done the problem, we're getting the balanced equation. You're given an unknown, your plan, and solve. So your theoretical yield is 0.488 grams of silver chromate. Let's do part B and get the percent yield. So the theoretical yield, we have the actual yield given to us in the problem. Use the percent yield equation, calculate, and your answer is 93.2%. And again, what does that mean? 93.2% of the expected amount of the product was actually recovered, which is a very good recovery. That, my friends, finishes our unit on stoichiometry. Goodbye for now. This is Mrs. Lethe.